So in three-dimensional geometry, anytime you are reading, have all the properties of a rectangle in mind. So as we are, you must see that this angle is 90. This one is 90. However much in the diagram does not look so. So you must have the properties in mind. AB is 20 centimeters. AB is 20. AD is 8 centimeters. The reach EF, which is 10 centimeters, 10 meters, is centrally placed. It means that it defines centrally placed. If we drop it here, whatever that will remain on this side should be equal on what is on this side, centrally placed. And then it is distance from here to here, it is the same as the distance from here to here. So it is at the center. It is centrally placed. So the faces ADE and BFC are equilateral triangles. ADE and BCF are equilateral triangles. So all sides are equal. So simply this one is 8 meters, this one is 8 meters, and this one is 8 meters, 8 meters. These are equilateral triangles. So with this information now we focus on answering the question. But of course we should have facts of what we discussed in three-dimensional geometry. The height of E above the base. The height of E above the base. I want you to see and then extract this trapezium. If we draw this line here to the center of DA and draw this line to the center of BC, we are going to have a trapezium. If we name this one as M and this one as N, there is a trapezium that we can extract. So we can come here and extract a trapezium. And extract an isosceles trapezium. So this is according to what we have. This is E, which is the ridge, and F, and then we have N and M. Hello, are you getting me? All right. Now, we are trying to analyze the figure before we answer the question. But the first question is the height of E above ABCD. So above ABCD, vertically above. So when we have extracted this trapezium E, M, N, F, the E above we are talking about is this distance. So if we drop this one and drop this one, remember EF was centrally placed, and the whole of this one is 20, so this is 10. What we drop down here will be 10. What we get here, it should be 5, and then 5. Because this one is a right angled triangle, it's an equilateral triangle. So if we drop a perpendicular from E to M, it's going to divide this one into 4, and then we work out for the height. So 4, we use Pythagoras theorem in this right angled triangle. This is 4 and this is 8. So which is this distance here? 8 squared 64. 64 minus 16. 48. Square root of 48. What is the root of 48? What?
6.9.
6.9.
Yes.
Yes, but let's work with that. But in the future, use 4 significant figures because we have calculators. So 6.9, this one is also 6.9. If this 6.9, 6.9, so we can find now h. H will be, this one will be the height of E will be equal to the square root of 6.9 squared minus 5 squared. What will be the answer? What's the answer? Those who have worked out 6.9 squared minus 5 squared. Then square root?
23.
No.
4.7958.
4.7, eh? 4.798. Good. So have you seen the movement, Chelsea? 5.8. Huh? 4.758.
Yes.
So Chelsea, are we together? That one has nothing to do with three dimension. It is just a question, eh? The height of C above the base ABCD. So using the idea centrally placed, so we extract a trapezium, and this trapezium, it is from the centers. Then using the trapezium, we find this height. This is the height we are referring to. Next question, the angle between the planes ABCD and ADFE. Let's go to the diagram. We want to draw lines now. When we are finding the angle between a plane and another plane, we identify the common line. The common line between the two planes. The common line is AD. AD is common. ABCD and ADFE. So identify the planes AB, ABCD. So A, B, C, D. That's the plane we are talking about, which is the base. And the plane AD, FE, ADFE. ADFE. ADF, then E. What is that? Plane ADFE. ADFE. Let's go with the what is known. How to find the angle between a plane and another plane, two planes. 1. Identify the common line. Identify the common line. After identifying the common line, drop a perpendicular, one from each plane, one on each plane. You draw two lines, one on each plane, and it must meet the common line at right angle. So with this information, let us try to draw. Let me use this one. So from F, I can drop a perpendicular to B to AD, which is our common line. And from common line, I can also draw another line to BC. Then if I drop a perpendicular from here to this side, we are going to see a triangle. A triangle that is behaving this way. There is this triangle here. And this triangle is at M. Then this is F. This one is, let me call this one O. This is O. So we follow what we know, how to find the angle between two planes. We must identify the two planes. I have identified them using red. Then identify the common line for the two planes. The common line is AD. Then draw two lines, one on each plane. We have drawn line FM and line MN. Then on those lines, focus on getting a right angled triangle. My right angled triangle will be FOM. FOM. So this is what I have. Let me now extract the heights. FO, it is the same as E to somewhere. Ile tulitafuta. This is 4.758. From M to O, it is 15. Why 15? Because it's only 5 which is missing here. E5. From M to O ni kama E. This is MF. This one is the angle we are tulitafuta hiyo height to katafuta up to here. It will be 5 plus 10 which is 15. We want this angle. So we can say tan theta is equals to, let me get somebody in, so from tan theta, this is the angle we have, the triangle we have extracted. So tan theta is equals to opposite 4.758 over 15. Tan inverse. What is theta? Theta is equals to? Theta is equals to what? Somebody? Theta is equals to? Where? Muko na calculators? Guys, you don't have calculators? Confirm whether we have 17.5, 17.6.
17.599.
Oh, so you round off, it can be 60, eh? Sindio? Are we in agreement? All right. Next, Roman 3, the angle between the planes AED. Let's follow the same procedure. Let me use let's follow the same procedure. We draw lines. Planes AED. Identify plane AED. A E D. That is the plane that I have drawn in that color. Plane AED and ABCD. Identify plane ABCD. A B C D. You can see the two planes. So identify the two planes in the diagram, AED and ABCD. Next, which is the common line? The common line is AD. Then draw two lines, one on each plane, but perpendicular to the common line. So one on each plane. Let me use this line here to M. A line from E to M. It means line AD, which is common, and a line from M to N. These two lines are meeting at AD and they are perpendicular to line AD. So the angle we are looking for is this angle here. So we can drop, by all means, get a right angle triangle. So from E, if I drop this line, it will meet line MN there. Then extract this triangle. So I have triangle. I have this triangle. The triangle which is at E. This one I don't know where it is, and this one is at M. Remember, this one was 754.758. Ile tulitafuta the perpendicular height, and this one is 5 because this small distance here is 5. So with the extraction of this triangle, we are looking for this angle. So you will still say tan theta is equals to opposite 4.758 over 5. So what is theta? Chelsea, are you following?
Yes.
Yes, and you should take the points where how we approach angle between two planes. Identify the planes. Get the common line. Draw two lines, one on each plane. Then find the angle between the two lines. So what is the angle? Those who have worked out. You are taking too long. Everyone is like, who should say first? Hata mimi niseme nikiwa wa kwanza, 43. Lois, that's what you have?
Yes.
43.58. Now our last question, the acute angle between the lines DB and EF. Identify the lines DB and EF. The lines DB, line DB, 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 and the line EF. Good. The two lines are not intersecting anywhere. How do you call lines that they don't meet but they are not parallel? Lois? Lydia? Hiyo nilikufunza. Lines that will not meet and they will not they are not parallel. You called them skew lines. Finding angle between two skew lines, we translate one line until they intersect. So if I translate line EF, if I translate line EF, it will land at line MN. Kuisongeza chini tu, it will land at line EM. So line EF, it lands at line EM. And wherever they will land, because it is the line which is centrally placed, and line LM, DB is the diagonal. So the diagonals will always intersect at the center. This is the line. This is the base that we have. This is the line MN, which is dividing it into two. DB is the diagonal. So we are finding the angle. The angle we are looking for is this one. Extracting a right angle triangle. This is the center. So this one will be 10 meters. And this one will be 4 because it was 8, so it divides this one into 4, and we want this angle theta. So our tan theta will be equals to opposite 4 over adjacent 10, and then you get theta, the inverse of 0.4. So I think here are the points that we are supposed to note. 1, we can get the angle between a line and plane. Angle between a line and a plane, for example, the line if this is M, which is the midpoint, the line EM and the plane A, B, C, D. So to find the angle between a line and a plane, we are supposed to identify the line. So we go and identify the line. The line is EM. Then find the projection of the line on a plane. Projection of a line on a plane. We drop a perpendicular from the end that is not in contact with the plane to the plane, and then we join. So drop the line EM, it is in contact with the plane at the M. So identify the line, then drop a perpendicular from the other end of the line to the plane, and then join. So we extract a triangle. So the angle we are looking for is this one, and we called this one projection. So the angle between a line and a plane, identify the line in the diagram, identify the common point between the line and the plane, drop a perpendicular from the other end of the line to the plane, join it to form a right angle triangle, and the line that you form after dropping and joining, it is called a projection. So to find the angle between a line, it is equals to this theta. It is the angle between a line and its projection on the plane. So this one is 4.758, and this one is 5. So you find the angle theta. Good. Another thing to note is the angle between two planes. Angle between two planes. That's what we have been working out. Angle between two planes, and the procedure is identify the planes on the diagram, get the common line, draw two lines, one on each plane, meeting at the common line at 90 degrees. Then find the angle between the two lines. Next is to find the angle between skew lines. Skew lines, lines that don't meet, and they are not parallel. Translate one line until they meet. For example, we had this line here, EF and line BD. These two lines will not meet and they are not parallel. Translate one line. If you translate this one EF, it lands at the middle of AD and BC. Then we get the angle between the two lines. And that's all about three-dimensional geometry. So it's all about drawing lines and extracting right angles. From the right angles, we can calculate the length using Pythagoras theorem, or we can calculate the angles using trigonometric ratios. And that is what we call it three-dimensional geometry. Wonderful. I want us to stop there.